Welcome back, guys. This is my 10th video for my channel Remote Explorations, where I post out videos and information about ISI, CMI, and other mathematical entrances, and act as your teacher, come educator, come guidance, come mentor. I am currently in my first year at IIM Bhubaneswar, studying for making mathematics as a career, and I have started a series of lectures which I is mainly focused at preparing you guys for mathematical entrances. My first chapter I had started was polynomials of today, whose lecture number 4 is gonna get live. So this is the lecture number 4, and this is the last lecture of polynomials, since from tomorrow I will be getting into sequence series or number theory. I will be seeing my priority list and then telling you guys. So today, the last class what we had done was Vieta's relations, a very important relation for solving up equations. Today is an extension of Vieta's relations, that is symmetric functions. What are symmetric functions? I've given up some examples. As you can see, my alpha plus beta plus gamma is equals to summation alpha. So from now on, to ease out our method of writing, we will be using summations. So alpha plus beta plus gamma is summation alpha. Alpha square plus beta square plus gamma square is summation alpha square. Alpha beta plus beta gamma plus alpha gamma is summation alpha beta. And alpha plus beta into beta plus gamma into alpha plus gamma is product of alpha plus beta. So that's capital pi for you, which denotes product. So how do you define a symmetric relation? A function f of alpha 1, alpha 2, alpha 3 up till alpha n of n variables is said to be symmetric if the function remains unaltered or unchanged by changing any one of the n variables. That is, if you change any one of the n variables of alpha 1 up till all the way till alpha n, my result remains unchanged. That is, my function remains unchanged. That's what a symmetric relation is. Symmetric relation and Vieta's relations go hand in hand. Not tough to see why, since it's basically using the same notations as your, what should I say, Vieta's relations. So next, our session today will be an average one, a 40-minute session around. I have taken up a question here, nice question. What am I given is, my x plus y is 1, x to the power 4 plus y to the power 4 is c. We need to find out x cube plus y cube and x square plus y square in terms of c. Okay, so easy one. Let's start doing it. Let's see. So what are we given? My x plus y is 1, x to the power 4 plus y to the power 4 is c. Now we need x square plus y square and x cube plus y cube. We all know x square plus y squares whole squares expansion is basically x to the power 4 plus y to the power 4 plus 2x square y square. We are also given x plus y is equals to 1. So x plus y is equals to 1. We can square it on both sides. X plus y is whole square is equals to 1 square is equals to 1. So we expand the LHS, that gives me x square plus y square plus 2xy is equals to 1. I want to separate my x square plus y square, since I need it for taking out my x to the power 4 plus y to the power 4. So my x square plus y square would be 1 minus 2xy. Cool. This is what am I getting, my x square plus y square. Let it be named equation 1. Now what can I do? I will be substituting equation 1 in this equation. Substituting equation 1. What's my equation here? X square plus y squares whole square is basically your x to the power 4 plus y to the power 4 plus 2x square y square. Putting in 1, what I can write? Just a second, I'm going in the correct way. Yeah. Cool. So x to the power 4 x square plus y square is basically 1 minus 2xy. We have a whole square over that. Then equals to x to the power 4 plus y to the power 4 plus 2x square y square. 1 plus 4x square y square minus 4xy is equals to x to the power 4 plus y to the power 4 plus 2x square y square. Time to, our main focus here would be to find out xy since other values can be taken out. So we basically get a quadratic of x square y square, which is evident from here. I will be taking all my things up to the LHS. So 4x square minus 2x square, that gives me your 2x square y square minus 4xy is as it is. And plus 1 here we are left with. So for minus 2, okay, minus 4 plus 1. And here we are left with x to the power 4 plus y to the power 4. Now, one thing to notice, students, is I need my answer in terms of c, since my x to the power 4 plus y to the power 4 is c. So, 2x square y square minus 4xy plus 1 is equals to c. So, 2x square y square minus 4xy plus 1 minus c gives me 0. So as we can see, this is my, to show it more possibly, 2xy whole square minus 4xy plus 1 minus c equals 0. So to show it more possibly, quadratic in xy. So time to use my Sridharacharya formula, which I taught in the last class. So my xy would be minus b plus minus root over b square minus 4sc by 2a. So minus b is minus of minus 4, that gives me 4 plus minus root over of b square minus 4ac. So 4 to 8 into 1 minus c by 2a, that means my 4. So my xy is basically your 4 plus minus root over of 16 minus 8 plus 8c by 4 again. My xy is 4 plus minus 8 plus 8c by 4. I can take my basically what common. This after further simplifying would be basically 1 plus minus 1 by root 2 into root over of 1 plus c. Cool. Done up till here. So my xy becomes this 1 plus minus 1 by root 2 into 1 plus c. Now What was our aim? Aim was to find x square plus y square in terms of C. Xy we know. X plus y is also known to us, I guess. So my x plus y is 1. Since x plus y equal to 1, therefore x square plus y square is basically your x plus y whole square minus 2xy. That gives me minus 1 minus 2 into 1 plus minus 1 by root 2 into root over of 1 plus c. Cool. Guess I'm okay up till here. That gives me 1 minus 2 plus minus root 2 into root 1 plus c. So that's minus 1 in plus minus root over of 2 into 1 plus c. So therefore, my x square plus y square equals minus 1 plus minus root over of 2 into 1 plus c. Cool to go? Now time for x cube plus y cube. Now this can be done in two methods. How? One is expanding x plus y's whole cube, and another is directly applying the formula of x cube plus y cube. I will be showing both the methods. So number one is expanding x plus y's whole cube. Cool. So my x plus y's whole cube is basically x cube plus y cube plus 3xy into x plus y. This is our expansion of a plus b whole cube, a cube plus b cube plus 3ab into a plus b, or a cube plus b cube plus 3a square b plus 3b square. My x plus y is known to be your 1. So 1 is equals to, we need my x cube plus y cube plus 3xy, and my x plus y is also 1. Cool. So my x cube plus y cube is directly 1 minus 3xy, which is equal to 1 minus 3. My xy had come out to be 1 plus minus 1 by root 2 into root over 1 plus c. 1 plus minus 1 by root 2 into root over of 1 plus c. So this was what my x cube plus y cube had come down to. So my 1 minus 3 plus minus 3 by root 2 into root 1 plus c. That gives me minus 2 plus minus 3 into root over of 1 plus c by 2. Cool. This is one way. So this is my x cube plus y cube. Another way is by expanding x cube plus y cube. Now, formula of a cube plus b cube is x plus y a plus b into a square minus ab plus b square. So my x plus y is 1 into x square plus y square minus xy. So that is ultimately my x square plus y square minus xy. I had taken out my x square plus y square. This is your minus 1 plus minus root 2 into 1 plus c. So basically it's your minus 1 plus minus root over of 2 into 1 plus c minus 1 plus 1 is 1 by root 2 into 1 plus c minus 1 plus minus 1 by root 2 into root over of 1 plus c. So again, we can find out my answer from here. I am not solving it further since my answer is going to be coming same. So that's how you do a symmetric equation problem. I guess I'm clear with it. Time to see some questions, nice ones. Find some good questions. I hope I can find it. Yeah. So I've got one nice question. This is actually a nice one. It, I think I'm not sure, but it had come in one of the previous PRMOs. So let's note it down, guys. Easy question. So basically, let me just give you a roundup story of everything we have covered before we start going on for a mixed bag problems. This is not there. This is common sense. We can use common sense, take each root to be alpha and solve it accordingly. So we started with polynomial functions. We defined how a polynomial function is and what are the properties of composition of polynomial functions, addition of polynomial functions and subtraction of polynomial functions. I taught you division, then came to important factor, then came to important theorems. One is the remainder theorem, another is the factor theorem, on which we practiced a good amount of questions, 3 to 4 round, and I also have a worksheet in this in the description box. Do see it in the description box down below. My next lecture I just moved forward with my various important theorems, in which came my very important rational root theorem and its again super important corollary, that is the integer root theorem, which helps us in finding roots easily and also in various derivation and proof cases. It then came in my next lecture the Vieta's relations. Vieta's relations is the relation of the roots and the coefficients of the terms in the equation. Then in my last lecture, or that is today's lecture, I just followed it up with corollary type, that is my symmetric expression, and I practiced one question which is a pure example of how a symmetric equation should be solved. Now, since we have revised all the things in very short, we are going to practice some 3 to 4 problems, nice ones. Then I'm going to end it and I'm going to give you a worksheet most probably tomorrow. So this was my notes for your agenda. That is my rational root theorem and integer root theorem. My lecture 3 was basically a continuation of my rational root theorem. Now comes up lecture 4, which is this one. So yeah, time for the question. Give me 2 minutes to think after I had done the question. Question. Prove that if the coefficient of the quadratic equation, prove that if coefficients of the quadratic equation ax square plus bx plus c equals 0 are odd integers, then the roots of the equation cannot be rational numbers. Then the roots of the equation so yeah, this is my question. I'm gonna solve it using my blue color. No, probably my red. Do give it a thinking. Okay. Time to solve this. We will try to solve this by the method of contradiction. That is, we're given cannot be rational numbers, we take the root to be a rational number. So let there be a root, rational one, of form P by Q. As a rational number, we have the following properties. Q cannot be equal to 0. P comma Q must belong to my set of integers, and GCD of P comma Q has to be 1. So naturally, since it is a root, I can put it in an equation to satisfy it. So A into P by Q whole square plus B into P by Q plus C gives me 0. That means A into P square by Q square plus B into P by Q plus C gives me 0. I can multiply all my terms in my numerator with Q square. So that gives me your AP square plus BPQ plus CQ square equals 0. Now, time to check out the parity. If we take P comma Q, both P and Q may be odd. Yes, it is possible. P comma Q may be alternatively odd or even. That is, one is odd, another is even, or the vice versa. The first one is even, the second one is odd. Cool. Another case is possible is both P and Q are even. Now, I need to strike out my last case. This is never possible. Why? What have we taken here? My GCD of P comma Q has to be 1. That is, the highest common factor of P and Q must be 1. That is, they have to be co-prime numbers. And if P and Q are even, they have a factor which is 2, which is something other than 1. That is not possible. So basically we have two cases. Both P and Q may be odd. P comma Q may be alternatively odd or even. Case 1, when both are odd. Now, my equation is AP square plus BPQ plus CQ square. If both P and Q are odd, then my AP square has to be an odd number. Since one more condition which I forgot to mention you guys is my A, B and C, I am holding it to be odd integers. It's an important question since many things depend on this. So when both are odd, AP square. Now square P is odd, A is odd. Square of an odd number is odd, and again A is odd. So odd into odd, it gives me odd. Check out the parity, guys. In this types of questions, we always need to check out the parity. That is the difference between odd and even. BPQ. P is odd, Q is odd, B is also odd. So three odd numbers are getting producted or multiplied. So that gives me odd. Similarly, CQ square. Q is odd, C is odd, Q square is odd, Q square into C is also odd. So my summation of three odd numbers has to be odd. Any cases you take it for 3 plus 5 plus 7 gives me 15. That's odd. Many examples. Any example you can take it, it's always going to be odd. And we know we need my summation to be 0, which is an even number. That is my LHS or summation of individual terms in should be even. So 0 is not an odd number, so this case is not possible. One case we have already struck out. Next case, when one is odd, other is even. What am I having? AP square plus PPQ plus CQ square. So then one is odd and the other is even. Let my P be odd and Q be even. Okay. AP square, similarly as in my first case, is odd. PPQ or CQ square. So my Q is an even number, so Q square has to be an even number, and even into odd, we all know is even. Here, B is an odd number, P is an odd number. So odd into odd gives me odd, and odd into even, which is my Q. So odd into even gives me even. So my summation of two evens is going to be an even, and my summation of odd plus even is always going to be odd, which is not possible for 0. The similar case happens if we take my P to be even and Q to be odd. One thing is changed, this becomes even, this becomes odd. Therefore, we have shown in the feasible cases that whenever my root is rational, my cases are not getting satisfied, hence there is a contradiction, hence it cannot have rational roots if the coefficients are odd integers. Hence contradiction occurs. Roots cannot be rationals. Root. Next. Okay, so I've got one more question. This also seems to be a nice one to me. Okay. Though it has some questions of sequences and some conserved sequence and series, but let's give it a try. Now, myself haven't tried this question, so it's my first time solving it live. I'm given an equation x square minus 3x plus a equals 0. It has roots x1 and x2. Similarly, we are given another equation x square minus 12x plus b equals 0, whose roots are x3 and x4. Cool. We are given some additional information, that is x1 is less than x2, less than x3, less than x4. Just a second, guys. Yeah. This is my condition, and I'm also given all of this 4 are in GP. Cool. What do we need? We need A dot B, that is A into B is how much? You can again see we need, so at some point of time we need the concept of eta. So let's solve it with light green. So my first equation is x square minus 3x plus a equals 0. I have my roots to be x1 and x2. So x1 plus x2 is 3. x1, x2 is a minus b by a and c by a, as made you understand in Vieta's relations lecture. Next one is x square minus 12x plus b equals 0. It has roots x3 plus x3 and x4. So my x3 plus x4 is 12. x3, x4 is b. We need a dot b, that is find out x1, x2, x3, x4. Cool. Now, one additional information, whenever we have 4 terms in GP, we can take them to be a by r cube, a by r, ar and ar cube, such that my common ratio remains r square always. My common ratio is basically the second term by first term, third term by second term, fourth term by third term. Here a by r cube gives me a by r square. I mean sorry, r square. A by r by a by r, ar by a by r gives me r square again. Now a by r cube by a by r by ar gives me r square again. This is how we take 4 terms in GP. I will be making you understand when I am doing the sequence and series thing. This is how you take terms. You generally let terms when solving a GP question. Now x1 plus x2 is 3. So this is my x1, this is my x2, this is my x3, this is my x4. My x1 plus x2 is 3. Since x1 plus x2 is 3, that gives me my a by r cube plus a by r is 3. That means a into 1 by r cube plus 1 by r is 3. This is my equation 1. One thing which is noticeable is if I multiply my x1, x2, x3 and x4 here, my all the r's get cancelled and I'm left with only one term, which is my a to the power 4. Interesting. So what we generally need, we just need to find out the value of a. So since x3 plus x4 is 12, x3 plus x4 is 12. This is probably the last question for today, and I'll be uploading a worksheet. So my AR plus AR cube is 12. If I take my A to be common, so R plus R cube gives me 12. Cool. That's my equation 2. Now what do? We divide equation 2 by equation 1. Now divide 2 by 1. That is R plus R cube by 1 by R plus 1 by R cube is equals to 4. So 12 by 3 is 4 and this side is this. R plus R cube. My LCM is R cube. So if I multiply, that gives me R square plus 1 equals 4. So in my numerator, I will be taking my R cube. So R cube into R plus R cube by R square plus 1. That is my 4. Now I can take my R square to be common. So R cube into R square into R square plus 1 by R square plus 1 is my 4. Cancel these terms. So my R to the power 5 is 4. This is what am I getting here? Now comes the interesting part. We need to find out A. This finding out A, I am going to leave it as a homework for you guys who are seeing the video to try to solve it, or else I will be solving it when I will be doing my GP. To make me remember it, guys, I will be solving it when I will be doing my GP. Since I want you guys to solve this, nice question, I have solved the main crux, but now what you need to do is you need to take out the value of A and send me the answer. That is A to the power 4. It should be easy. On hint, you can just square up or raise to the power 4 for any of the equations. That would, I guess, make the cases better. So, okay guys, that's it for today. And here we finish up polynomials for this season, or this session I should say. Polynomials ended. Next, tomorrow I'll be starting up with most probably either NT or not tomorrow, day after tomorrow, either NT or sequences and series. Practice materials for this chapter: tomato, the distance of mathematics at 10 plus 2 level, or Pathfinder for Mathematics Olympiad, the not the outer exercises. You can go for the solved problems or the inner exercise sets. These two, and if possible, do look at the concepts of Challenges and Thrills of Pre-College Mathematics by New Age Publications. Challenges and Thrills of Pre-College Mathematics. So yes, that's it for today. I have wrapped up my teaching of polynomials in 4 lectures. Do give it a revision. Let me see if I can provide you the notes, but that won't be in my YouTube channel. That would be in my blogging site. That is sunnylovesmath.blogspot.com. Do go and do follow it. Yeah, that's all for today. See you guys with my next chapter. I hope you guys like the video, and do subscribe it and do share it with your friends who are going up for this prep. That's for today, guys. Goodbye.